Algebra 2. This is the start of Chapter 9. So we're going to look at Lesson 9-1, which is inverse variation. We did direct variation earlier in the year. Those are the ones that I told you were like the 1-second problems that were not that bad to solve. So we're going to start off Chapter 9 pretty simple. So inverse variation is y equals k over x, where k is your constant of variation. And k also equals xy. When I solved for k, back when we solved for formulas, all I did is multiplied that x across. So keep in mind, k is x times y. And then remember previously when we did direct variation, y equals kx, where k is y over x. So what they're going to ask you is, if you're given two tables, determine which one is a constant, or which one is an inverse variation and which one is a direct variation. So the first thing we need to find is a constant term, something that is happening consistently every single time with the numbers. So you're either going to be multiplying them or dividing them to see if you have a constant of variation. So I look at these two groups, my x and my y. So I look, 2 times 0.7, 1.4. 4 times 0.35, 1.4. 14 times 0.1, 1.4. So I multiplied. Therefore, I have an inverse variation. So this would be an inverse variation, with k equaling, what did I say k was? 1.4, because every time I multiplied those, it was 1.4. So when I'm writing my equation, I come back up here. Don't plug in the y values. Just use y as the variable. Y equals, plug in your constant over x. Done. It's that simple. Down here, if I'm looking at these, I'm going to go with the multiplying first. Well, that's -10, -40. I already know it's not going to be an inverse variation. So now I divide. I do my y over x. So this is going to be 5 over -2, which is -5 halves. -10 over 4 reduces down to -5 halves. -15 over 6, that also reduces down to -5 halves. So now I have a direct variation because I divided. So my direct variation would be y equals, what did I say my k was? Yep, -5 halves. So y equals -5 halves x. Again, just plug your variables back in. Don't plug numbers back in. Okay, so you're also going to be asked, if you're given an ordered pair, write the equation of the inverse variation. Well, the first thing you need to have is your k. Well, we know from inverse variation, k is x times y. Okay, so k equals x, y. So just multiply those two. Your k is 14. Now write the equation. Y equals k over x. It is that simple. Okay, so I found my k equals xy. K equals 14. I just multiplied those two. 1-second problems, guys. Y equals 14 over x, because that's what the equation tells us we need to do. Okay, when you get down to problems like number 17 and those where they want you to describe what's happening. So when you get down to like 17, I know this is a direct variation. Why it's a direct variation? Because I'm multiplying my k times my x. Okay, so in equation form, this would be a direct variation. In equation form, if I had something like this, that's an inverse variation. So to describe this, I would write A varies jointly, because two things are happening here, with B and H, where K equals 0.5. I know that the book doesn't put that in there with describing the constant variation. Make sure you guys put that in there. Tell me what that K is. What doesn't change? And if this is an area formula where it's 1/2 base times height, area of the triangle, for those that were just a little bit curious again, when you have the 0.5 BH, your base and your heights can always change on a triangle. The thing that does not change is that 0.5. That 1/2 does not ever change its value. That's what makes it a constant of variation. So if you have something like, let's say A equals pi r squared, that pi is your constant of variation. That never ever changes. That stays as pi. The r is what changes. Your radius is what always changes. So if I were to describe this one here, I would say that a varies directly with r squared, or a varies directly with the square of r, where pi is my k. And if I were to describe this one up here, I would say y varies inversely with 14 and x, because that's an inverse variation. So there were three different ways that I could describe what is happening in an equation. And here I would say 14 is my constant of variation, because that's the one that's not going to change. That's the k that we found. So down below here, on the rest of these, they're going to ask you to find the missing variable. Okay, so if you're dealing with a direct variation, remember direct variation, again, is y over x. Okay, so my direct variation is y over x. So I'm going to set up my proportions. 7 over 3 equals y over 8. Cross multiply to solve. 56 equals 3y. Y equals 56 thirds. That easy. Okay, so again, I set up my ratios. Y over x equals y over x. 56, when I cross multiply, because when two proportions are set equal, you cross multiply to solve. 56 equals 3y. Divide by 3, y equals 56 thirds. And then the inverse one. Okay, remember, inverse is x times y. Okay, that's the difference between those two. So if I'm taking my x times y, I would take 21 equals 8 times y. So 21 over 8 equals y. That simple for those. Okay, those are definitely ones you just don't want to overthink. They're pretty straightforward and pretty easy. So there it is today. Inverse variation. I will post later the assignment in your Google Classroom.